Welcome back to the chemistry session. Today we are going to discuss about previous year's questions related to chemical energetics. The first question, bond energy is the amount of energy in kilojoule which must be supplied to break 1 mole of the bond. The values are given in the table. Based on the table, we are going to solve. First of all, we are going to check bonds broken. Look at the reactant side. How many CH bonds are there? 1, 2, 3, 4, 5, 6. 6 CH bonds plus how many CC bond? 1 CC bond plus 1 C double bond C plus 1 HH bond. Now we are using the values from the table. 6 into CH value is 415 from the given table plus CC value 346 plus C double bond C value 610 plus HH value 436. CH value 415. Multiplied with the 6 plus 1 CC bond, that is 346 plus 1 C double bond C 610, 1 HH bond 436. Once you are calculating the total, 3882 kilojoule per mole. 388 kilojoule per mole. Now we are going to check bonds formed. Bonds formed. Look at the reactant side. How many CH bonds are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 CH bonds plus 8 CH bonds plus how many CC bonds are there? 2 CC bonds plus 2 CC bonds. We are going to substitute the value 8 into CH value 415 plus CC value 346. (4012) kilojoule per mole. Now we want to calculate bond energy. Bond energy is equal to bond energy equals bond breaking minus bond making. That is bond formed. Bond breaking minus bond making. So substitute the value 3882 minus 4012. Answer will come minus 130 kilojoule per mole. Minus 130 kilojoule per mole. Look at the answer. Here the value is negative sign, right? So this reaction is an exothermic one. The reaction is an exothermic one. The reaction is an exothermic one. Reaction is an exothermic one. You want to mention that also. This reaction is exothermic. Move to the next question. Second question. Calculate the overall energy change for the reaction between iodine and chlorine using the bond energy values. I2 plus Cl2 gives 2 ICl. Here you want to write bond breaking. Bond breaking. Here I2. What is the value of I2? 151 plus Cl2 value 242. Answer will come 393 kilojoule per mole. Now bond making. Bond making. Here 2 ICl molecules are there. So 2 into 208. 416 will come. Here the question is only calculate the overall energy change. So bond making time, you want to mention negative sign. So you must give negative sign for the bond making. Next one, second part. You want to draw labeled energy level diagram for the reaction between iodine and chlorine using the information. The diagram shows an exothermic reaction. So you want to mention exothermic reaction diagram. So the reactant on the top side and product on the lower side. At the same time, you want to mention activation energy also. Now, next question. The combustion of propane C3H8 is exothermic. Give an equation for the complete combustion of propane. Here you want to check the question given complete combustion. Complete combustion means the product are carbon dioxide and water. So the equation is C3H8. You want to write subscript C3H8 plus 5O2 plus 5O2 gives 3CO2 3CO2 4H2O. Next one, photosynthesis is an unusual endothermic reaction. Where does the energy comes from? Answer, sun. Or you can write sunlight. Give the word equation for photosynthesis. Next question. Carbon dioxide plus water is word equation. Carbon dioxide plus water gives glucose plus oxygen. Glucose plus oxygen. That is the word equation. Move to the next question. What is the difference between endothermic and exothermic reaction? You can make one table format, otherwise you can write one by one. Now I am going to first of all mention endothermic reaction. In endothermic reaction, heat energy is absorbed, while in exothermic reaction, heat energy is released. According to this question, total mark is 1, so you want to mention only one difference. Now move to the next question. Bond breaking is an endothermic process. Bond energy is the amount of energy needed to break or form one mole of the bond. Complete the table and explain why the forward reaction is exothermic. Nitrogen combines with hydrogen to form ammonia. You want to complete the table also. So in the given table, first of all, they mention hydrogen 436. So it is endothermic or exothermic. The value of energy change is plus. So it is an endothermic reaction. Second one, NH. How many NH bonds are there? There are 3 NH bonds. So NH value is given 388, but it is 2 molecules. So 2 into 3, 6 into 388. Answer 2328. That is exothermic because product formed. Exothermic. The question, why the forward reaction is exothermic? So you are going to calculate the energy change value. First of all, we are going to write bond making or bond formed. Bond making. Bond making, there is N triple bond N. There is only one molecule. So 1 into 944 plus P into 436. Answer will come 2252 kilojoule per mole. Now bond formed. NH bond, 3 NH bond, 2 molecules are there. So 6 NH. 6 NH. 6 into 388. 2328 will come. 6 into 388. 2388 will come. Now energy difference. Energy difference equals bond making 2252 minus 2328. Answer will come minus 76. Look at the question. 2252 minus 2388. So your answer will come minus 136. So the energy difference value is minus 136 kilojoule per mole. So the given reaction is exothermic. Always remember, if the energy difference value is negative, then the reaction is exothermic. Move to the next question. Use the bond energies to show the following reaction is exothermic. Bond energy values are given. Bond broken, energy is given, then bond formed. So here you can directly apply. How many CH bonds are there in bond broken? There are 4 CH bond. 4 CH bond. 4 into 412. Answer will come 1648. In ClCl bond, ClCl bond 1 into 242. That is 242 will come. Total energy 1648 plus 242. 1890 kilojoule per mole. Now we are going to check bond formed. Now we are going to check about bonds formed. Okay. The product are CH3Cl. How many CH bonds are there? 3 CH bond. So 3 CH equals 3 into 412 equals 1236. 1 CCl bond. 1 CCl bond. equals 1 into 338 equals 338. 1 HCl bond 1 into 431. 1 into 431 equals 431. Now we are going to calculate the total energy. Now total energy 1236 1236 plus 338 plus 431 equals 2005. Now we are calculating bond energy. Bond energy is equal to bond energy is equal to bond energy is equal to bond making minus bond breaking minus bond making. So 1890 minus 2005 equals minus 115 kilojoule per mole. Kilojoule per mole. That is, the reaction is exothermic. The reaction is exothermic. Always remember, if the bond energy value is negative, then the reaction is exothermic. Now move to the next question. Hydrogen and oxygen react to form water. Give an example of bond breaking in the above reaction. Bond breaking means it is in the reactant side. So either you can write hydrogen, otherwise in the form of oxygen. So now I am preferring hydrogen. So the bond breaking is H bond H. Otherwise you can write O double bond O. Give an example of bond forming in the above reaction. Here the product is water, so the bond forming is OH. Otherwise, you can write bond formed between hydrogen and oxygen. Is the change in one is exothermic or endothermic? Answer endothermic, because bond breaking. Endothermic. Give two reasons why hydrogen may be considered to be an ideal fuel for the future. First one, no pollution. Second one, no oxides of nitrogen. Does not use fossil fuels. Next one, byproduct is water. Byproduct is water. Byproduct is water. Thanks to listen.